Hello everyone. Are you all excited for the day two? I would request everyone to write excited or hi in the Q&A session. We will wait for a while until all the people join in, and then we can start. I guess we can start now. In day one, we have covered a lot of topics like what are the use of this keyword, then final, then we did about different topics. So today we are going to start another important topic of groups, that is inheritance. Now that I told you yesterday that inheritance is nothing but it is kind of inheriting properties from one class to another class. Like we inherit properties, some properties from our parents, their traits, their characteristics, and then we have some properties of our own individual properties. Likewise, in a Java program also, once you have written a code and you want to use the same code a lot of times, then instead of writing that code multiple times, you can just inherit that class into your class so that it would help us to gain the reusability of the code, and we would be able to show only the characteristics of a parent class into a subclass as well. But the inverse is not true. Like you cannot utilize the properties of the subclass from the parent class. So you can just have the properties of the parent class from the subclass. And that would have a lot of different types, single level, multi-level. So what is actually single level? When there is class A, which is the parent class, and we have class B, which is our subclass. So when one subclass is inheriting the property of one parent class, then this is what is single level. If it's only this much, then it is single level. But if it's multi-level, then we will have another C, which will be a subclass, and for C, the parent class would be B. So this is what is referred to as the multi-level. So in single level, we had one parent and one subclass. In multi-level, we had one parent and two parents and one subclass present. It's like single level is your father and yourself, and in multi-level, you have your grandfather, your father, and then you. So then what will happen that class B would be able to inherit the properties of class A, C would be able to inherit the properties of B, and B comes up with the properties of A, so C can inherit the properties of B and A both. While B can inherit only the properties of A, and A cannot have the properties of B and C. Okay, now next what we have is hierarchy. So now here what happens is, here we have a class A, and then we have class B, and we have class C. Now from A, B can inherit, and from A, C can also inherit. It's your parent class, and this both are your subclass. Now it's like this is your father, and then you have a sister, and this is you. So your sister and you are at the same level, and there is one parent class over you. So this is what is hierarchical inheritance. Now we have this. Now the opposite is actually not possible. Like multiple inheritance is just the opposite of it. In multi-level, what we have is we have A B, and you want to have both inherited into your C, into yourself. Like this is your parent and this is your parent, and you want to get that in S, like in yourself. That is a subclass. Now, this is what is actually multi-level inheritance, but this is not possible in Java using normal class. Using class, you cannot have multiple inheritance because for inheritance, the basic keyword which comes is extend. And extends you can have only one class name, comma B is not possible. So we can have only one thing, like only one of them inherit, like single level present. But we can do it in a way that is using interface. If we use interface concept, which we are going to see later, then we can implement this multiple inheritance thing. So using class, we cannot have this multiple inheritance used. And hybrid inheritance is when we are using more than one type of inheritance in a code, then it becomes a hybrid kind of inheritance. So the main thing which we have is, which we must keep in mind, if we have to inherit one class into another class, then this is the keyword, the extends is the keyword which we need to keep in mind. Like class A extends B. Okay, so here B is nothing but our parent class and A is our subclass, and we are giving the properties of B into A properties. Okay, and the like this is parent class, superclass, and this is child class or subclass. And this is what is multi-level inheritance is possible, but multiple inheritance is not possible, which I said just a few minutes ago. So that can be used doing interface thing, which we will learn a few slides later. Now see, this is kind of inheritance. Like what we have is, uh, here we have a parent class that is vehicle, and then we have two children class that is car and motorcycle, inheriting the properties into vehicle. So as I said you that if there is a class A and there is two child class B and C, both inheriting the properties of the parent class, this type of inheritance is referred to as the hierarchical kind of inheritance. So this is hierarchical inheritance. Then this is an example of simple inheritance like what we have class A, B is extending class A, that means A is our parent class and B is our subclass, and then we can define its own properties. And now if you see that there are I and J variables used here, I and J variables. Now I and J variables are not an attribute of class B. Like class B does not have any I or J present in it. So here we are using I and J. So that is why the properties of class A, like I and J are the properties of class A. So as we have extended, like we have inherited the properties of A, so we can use I and J variables of A. Now if we create I and J values of B also, like if we have I int I comma j here as well and we put some values in it, then so as to refer this, like if you want to refer the I and j of the parent class, then simply use the keyword super. If we use the keyword super dot I, then it would help us know that okay, this I is of the parent class, and if it's normal I, okay, then this I is of the subclass. So this is what happens is, like if we create a object of A, so we have created an object of A, then we have given the initialize the value of I, we have initialized the value of J, and then we are writing with the object of the parent class, we can call only the function which is present in class A. If we try to call show k or sum from class A, then it would show error. And when we are having object B, then with the object of B, we can initialize all I, J, and K, all the three attributes, all the three variables. Even the properties of A can be initialized from class B. And then we can call the functions of the parent class as well as its own properties. So this is what is actually a single level inheritance. And then like here we have a similar kind of thing, but there has been a keyword which has been added, that is private. A keyword private has been added. So as we saw yesterday, that if private things are there, like private data variables are there, then it is accessible only within the class and nowhere else. So here if we try, if it is private and if we try to access it in our a child class, then that would not be possible. It is simply because of the reason that private data variables are only accessible within the same class and not even within the subclass. If we try to access that, it won't be accessible to us. So now we have a subclass with a constructor. Like here we have a class that is like person, and then we have defined a constructor in it, that is again a person, and then we are creating a constructor of the parent class. And then if we have another constructor like student constructor, and then we have the constructor of the child class. So now what will happen is we have when we create the object of the child class, like if we create the object of the parent class, then it is simple that the constructor of parent class could be printed. But if we call the constructor of the subclass, that is child, if we create its constructor, like we create its object, then before the constructor of child class is there, the parent class constructor would be called, like constructor of parent class would be there, and then the constructor of child class would be printed. That is why sometimes we use like the keyword super, like here we use the keyword super, and then we just like this. So this shows that the construct automatically the constructor of the parent class would be called. Then next thing which we have is the creation and initialization. Now the creation and the initialization of the subclass is like when you call the subclass instead of the superclass, then we can initialize the superclass as well from the subclass. Like if we have any parameterized constructor in the superclass and we want to give values to it, then what we can do in the subclass constructor is just write super and in the bracket gives the value. Like if you want to have the values of x and y, then this would automatically call the constructor of the superclass, give them, assign the values, and then the code would run perfectly. So the superclass data variables can be initialized from the subclass as well. But if we create the object of the superclass, then it would only invoke the superclass constructor. It won't be able to access the subclass functions and data variables. Now next, as I told you the importance of super. Like super is a very important keyword when it comes to inheritance. Like inheritance has generally two keywords associated with it. First is extent, which is very important to inherit the properties, and the next one which comes is super. So these two keywords are really important when it comes to the inheritance part. So this keyword, super keyword, would help us to differentiate, as I told you, that if we have I variable in superclass, we have I variable in subclass, we want to access the superclass, then we will write super dot I. So super dot I would be accessing the I value which is present in the superclass, and if we have only I, then it would be accessing the subclass I. And like as I told you, if we have only super written with bracket close this would automatically invoke the constructor of the parent class. If it is parameterized, we can give some data variables here, and then it would be like that parameters would be assigned to that given values of x and y, whatever is being declared in the superclass. So this is the thing which we have already discussed. And one more thing is like if you want to change the value of I variable which was there in superclass, so we can write super dot I and then we can equals to I like this. So this would be of the subclass and this would be of the superclass. So it helps us to avoid confusion in case of inheritance. Like for say a class, we have the keyword this in constructor. If we have like different function but within the same class, then we use this keyword. Same thing if we have to do it in the inheritance class, we have to use the keyword super. Now like we have a class C and we are extending that class C into D. Now it has I variable of itself and the superclass also had I. So what we are doing is super dot I equals to a. Now we are assigning the value a into this variable. The variable of the super class would be like having the value which is stored in a, and b would be stored in the this I of the of the subclass. And then if we print, we can print super dot I to remove like confusion that okay, this is of the parent class while this I is referring to the subclass. So this is what is the importance of your super keyword. So now when we are giving like 1 and 2, 1 and 2 will come to the constructor of the subclass. Then the value of I would be changed to 1 and this I would be changed to 2. And if we do show, then what will happen? We have same show here and we have show in the parent class as well as in the subclass. So the subclass function would override the main parent class show function, and this too will be printed, but explicitly we are calling super dot show that would be calling the function present in the parent class. So this is done explicitly by us. Now, like if we have a protected keyword like for 2 or 3, we have 3 data variables like name, salary, and birth date, which are all protected. So it can be accessed with the same subclass also we can have. Now we have here another extends thing which has a department kind of thing, and then we are taking name, salary, and date of birth, which we are assigning it to the super. Like this name, salary, and date of birth would be going and getting stored here, and they would be initialized later on. And then we will get department as well, and then we can access any of the data variables. As it is protected, it can be accessed within the subclass as well as within the class as well. Now this is the example of multi-level inheritance. Like we have X, we have a constructor of X, we have Y, which extends X, and then we have constructor of Y, then we have Z, which is extending Y. So how does the like structure look? We have X, it is being Y, and then Y is being inherited by Z. So it is like the parent class for Y, it is the subclass for X, and then it is the parent class for Z, and Z is our subclass. So when we are creating the object of Z and we are entering the value of A, B, and C, so as Z is extending Y, it is getting access to B. As Y is extending X, it is getting access to A as well. So all variables A, B, and C would be assigned 10, 20, and 30. Now, when you're creating the object, the constructor of Z would be called, and before the constructor Z inside Z constructor gets implemented, before that explicitly we have like implicitly we have the constructor Y which is being called, like constructor of Y is being called. Now before getting this included, it also implicitly has the command of executing its parent class constructor first. So that is why inside X constructor would be first, then inside Y constructor, and then there would be inside Z constructor. So the pattern would be from your great like grand parent class, it would be the execution would start in case of constructor. But if it was like we had same function name, then it would have been overridden that we could have called explicitly using the super keyword. Now this is the kind of multi-level inheritance. We have shape. Then for shape we have a rectangle, and then that rectangle function can be inherited by square again, and they have some properties of their own. So this is how a multi-level inheritance looks like. So these are the basic like for if you ask about like the basic types of inheritance, so these are the kind of inheritance because single level, multi-level, and then your hierarchy. These three are the main types of inheritance. Multiple inheritance would be using interface, and hybrid if you combine any of these inheritance techniques, then that would automatically be uh, that would automatically be your. So now we have polymorphism. Now polymorphism is like when something is working differently for different situations. Like if we have the term area, area would work differently for different situations. Like if it is a square, it would be finding using the formula side into side. If it is a rectangle, then it would be length into breadth. If it is circle, then it is pi r square. So for different situation, the same word is treating differently. So this is what is actually the polymorphism thing. So now we have polymorphism, which can be of two types. Like we have one thing which is compile time and one thing is runtime. Now what is compile time and what is runtime? Like if we have operator overloading and method overloading. This all things what will happen during the compile time only. The compiler would be able to understand. Okay, there are same function name, but they would have one parameter which would be changing, like the number of data type, data variables, the data type of variables would and the sequence of your variables would matter. So we have a clear differentiator that okay, this function is being called at this moment. While in case of runtime, both the parent class and the child class both are having the same function name and they are having the same everything which are same function definition to be exact. So that time what actually happens during the runtime, the compiler will override, like it will execute this subclass function and the parent class function would not be executed. Like there is kind of a priority given to the subclass function. But if you want to call it explicitly, we can use the super keyword and call that same function present in the parent class. But during the runtime, this is what is being done with the function. So this is what is actually runtime and this is what is actually compile time. So when there is a clear differentiator, then it is done during the compile time. But when there is no differentiator, whole function signature or definition is same, then we will have it during the runtime that will be done to method overriding. So this is what is different kind of thing. Now, operator overloading. Okay, this one more thing, that is operator overloading. Now, what is actually operator overloading? The best example is plus sign. Now, when we write a plus b, when a and b are treated as integer, like 5 plus 10, it would appear as an arithmetic operator and it would give us the result 50. But if I treat something as string, this. So what will happen now? It would be concatenated and minus already would come. Okay, so this is what is like here. It is not acting as an arithmetic operator. Instead, it is acting as a string operator and it is concatenating two strings. But in case of plus, what happens is a plus b, that is 5 plus 10 equals to 50. In that case, it is acting as an arithmetic operator. So overloading is like static. It happens during compile time, while overriding happens during the runtime, which we have already discussed. Yeah. So as we have already seen what is method overloading and all, let's refer to it once again. So like here we have difference in the signature. It has no parameter. It has one parameter. So during the function call, if we are giving any value like add 10, then this would be called. Only add, then this will be called. Here we have two data types. Now here we have int and we have float. Now if we give add 10, then this would be called. If I write add 10.2, then your float function would be called. And then here we have the third thing as I said, if we are changing the sequence, first we are giving 10 and then 10.2, or else first we are giving 10.2 and then we are giving 10. So these are the three ways through which at the compile time we can implement polymorphism, and this is overloading as we are giving a particular differentiator during the compile time. So it can be handled during the compile time and it is static in nature. But if it would have been like overriding where it cannot be done during the compile time because of it being dynamic, as there is no clear differentiator present. So like what are the example, like if we only change the return type, then it is not going to be a, if you only change the return type, then it's not going to be overloading, simply because when you are calling the function, that is the time when the main execution of your code is happening. At that time, you are not aware whether this function would be returning any value or not. You are just interested with the function name and the parameters. Whether it would be returning anything or not is not under our control. So it's clear that which function would be accessed at that time, it won't be any thing for us. Now, if we change the type, like static, or if you do void, it does not make any change. Like changing, just adding static keyword and that won't help us in differentiating the two. And if it is like this is what is actually this example, the third example, this one is like if I extend here, extends test, then it would be the example of overriding. This is what is actually overriding. Same kind of function, similar, exactly same function definition, just that one is in the subclass and another one is in the parent class. So that is what becomes the difference. Now overriding. Now for overriding, the sort of things they have like same argument list. As I said, they should have the same function definition, so same argument list, same return type. Then it must not be a more restrictive access modifier like If it is private, then it is like your person, like the employee function, employee class, sorry, employee class, which is inheriting the properties of the person, will not be inheriting the display function, because if it is made private, then it would be accessible only within the person only. Then there is no possibility of function overriding when you have only one option present with you. So it would be when it is public protected, less restrictive access modifier. In that case, the overriding it takes place, but in case of private, overriding won't take place. And so there must be a less restrictive access modifier. And if there is final methods or static methods, like if we have already declared this final, then that is one of the things that it would not be overridden, and the final function would be executed. So that is why the final method can never be overridden. This is what is one of the properties of the final functions or class. Now, if I write final in a class person, then it won't be able to inherit, like employee won't be inherit anything from the parent. And like if you like, we can, like as I said, if we having the same definition, we can explicitly call the function, that is the function of the parent class, using the super keyword. Because if you are using super dot display, it would understand that this is the function of the parent class. So this is how we can explicitly call the function of the parent class and then get the subclass thing executed. But if that super dot display is missing, then obviously your parent class function would be overridden by the child class function. So now, next thing which we have is the difference between a program and a process. Like in a program, we have data and we have instruction. And then when your program is loaded into your memory, then along with your data instruction, there comes a stack and heap in which your memory is working, and that becomes a process. And in this thing, we have the usage of concepts like multi-threading and before going into multi-threading, we should understand abstraction. So what is actually program? Program consists of set of instructions in programming language. Okay, so it would be having a set of instructions, while process is a sequence of instruction which is execution. Like which instruction would be executed at what point. This is what actually process tells us. And a program is a static object existing in a file form, while process is nothing but it is a dynamic object. And program is loaded into the secondary, because it is when it is executing at that time, the things are loaded into the main memory, and which makes it a process. While programs time span is unlimited, like it will go on once we start executing, it gets start get executed. But process is like when it your line of execution is there, it would return something, and then it would go to the next executable line. Like this, it would continue, and then at one point we will come to an end. So the time span of a process is limited. Like we write different codes and we make it into a process, and then we call it at the time whenever we require it. That is why program is passive in nature, while process is always active in nature. Yeah. Next thing which we comes is the difference between a process and a thread. Like so before that multi-threading, we should understand actually what is actually abstraction. So as I said, abstraction is nothing but when we are showing only the essential details and we are not showing the background details. Like in an ATM machine we can see the following things like check balance, deposit cash, withdraw cash. But how, what are the things going in the back end, we are unaware of. So it is only showing us the things which we require as a user and it does not show the background details. So that is what actually is in the interface like any website you use. We will be only accessible to the outer interface, whatever, how is the backend working in backside. That all things are not shown in front. Like only essential details are shown so that there is data security. So in abstraction, we have so as to like only show the front details without showing the background details. We have two things which need to be done. Either it is an abstract class or it is an interface. So it is either of the two. Now in case of abstract class, we can have 0 to 100% of data abstraction, while interface is always 100% abstraction. So let us understand them in detail. So, what are the things we must keep in mind if we look at the syntax thing? So, abstract must have a abstract keyword. Like if we have abstract written abstract, then we can write class, and then we can write the class name as A. Then it like in abstract class, as I said, there is 0 to 100% abstraction. It is simply because of this line that we must keep in mind that in abstract class we can have abstract as well as non-abstract methods. So as we are having abstract as well as non-abstract methods present in it, so it is going to be a abstract as well as a non-abstract class as well. Like it can be a normal class as well as an abstract class. So if there are all non-abstract methods, then this 0% would come into action. If they are all abstract methods, then 100% would come into action. And based on the worst case and best case, in between this, we have the things in which both abstract and non-abstract methods are there. Now, it cannot be instantiated. That means we cannot create an object for this and call those abstract things. So it can have constructors as well as static methods present. Okay, so these are what are the basic fundamental qualities of this, but the main thing is that it can have abstract as well as non-abstract methods and it cannot be initiated and it can have constructors and static methods present in it. So like if we have this shape, and then we are having rectangle and circle. So here what is happening, we are having a hierarchical kind of uh, inheritance. Like if shape is the parent class, then we have rectangle and circle, which are the child class, and all have a function that is area. So when we have like, so this is what is actually our abstract class. Now what we have done is we have used the keyword abstract here. We have used the keyword abstract here. That means this method can have abstract function as well as non-abstract function. Now, how does the abstract function look like is abstract void call. An abstract function always needs to be overridden. Like in another function, we need to override that thing in case of abstract function. So we have abstract void call. So we have created a function signature with a semicolon. That means that the abstract method will never have a body like function body. So we have abstract void call and we have a semicolon and we have created one a normal non-abstract method. So we can say that it is 50% abstraction. It is kind of 50% abstract. And we have a class T which is extending S, which is extending an abstract class. So as it is extending an uh, abstract class, so what we have to do is abstract methods needs to be like overridden for sure. So we have written void call and then we are overriding it. So your call function is being overridden. Then we can call the object of the parent class, like sorry, subclass, and we cannot create the object of the parent class because your parent class is abstract class. And the third point, as I said you, that the like the abstract class cannot be instantiated. That means we cannot create an object of the abstract class. So here if we do call, it would be override and the implementation of call, and then we can directly, if we write overridden, it would be overridden. Even if we don't override it, then we have a well-defined function defined the abstract class that we have inherited that we will use. So this is what is abstract method. Like if it is inheritance, like if it's an abstract method, you need to keep in mind that the subclass has to override the method of its superclass. Like only the methods which are abstract, it compulsory needs to override them if you want to execute that thing. So concrete may be overridden, like that what I said. If we have an abstract and a non-abstract function, so the abstract thing always needs to be overridden. Non-abstract, it's up to you whether you want or whether you don't want. It's compulsory up to you. And like we cannot define abstract constructors as well as we cannot have static methods present in it because if it's static and all we cannot override it, and abstract constructors cannot be created because it cannot be instantiated. So once it cannot be instantiated, that means we cannot create the object, and we know that the constructor is explicitly called during the object creation. So if object is only not created, then what is the use of creating our function? Our function, like sorry, our creating our constructor. So like it's perfectly acceptable. Like if you implement a concrete method because it is 0 to 100%, and this thing up. So like if we have abstract, like employee, we have abstract class, we have abstract function. So it is for sure that in both of the like in any of the hierarchical or any inheritance, when you would be inheriting this employee class, it is compulsory to find the calculate salary in your class diagram. So this is what is actually a class diagram. So you have found out that okay, we have got the class, like in the class diagram, we have the abstract method present in it, which is a very important criteria. And then we can have parameters of our own if needed. If not, we can access the parameters of the abstract class as well. So we are done with that section. Next thing which we will notice. So next thing, firstly we saw abstract class. In abstract class we saw that it might be 0% to 100%. So like still there is a scope that we have data hiding that is not that much prominent, but we have a considerable thing. Now interface is always 100% abstraction because in interface we don't have any other functions or things, it has only abstract methods in it. So whatever is written in the interface, if any of the function defined in the interface, if they are to be called by another class, like it has to inherit the interface, then it compulsory needs to override all the functions defined in the interface, because in interface all the functions would be abstract functions. So it's like 100% abstraction needs to be achieved. So there, and one more thing, as I said during the inheritance, that multiple inheritance can be initiated only using the interface thing. So we would be able to have the multiple inheritance where one class was having two different inheriting two different classes, that would be possible with the help of interface only. So these are the two main reasons for which the concept of interface has come into action: abstraction and multiple inheritance. And the interface is a collection of nothing but it has either abstract methods or it has final variables. Only two things it can consider. And even if you are not giving any abstract keyword or you are not writing any access specifier inside a function which is being defined inside the Java interface, then the Java compiler by itself will add public as the access specifier, and it would add the keyword of abstract. Then we will have the function defined as defined in the interface. So the compiler will itself add the words of public and static and public and abstract before the interface method. And if it is a variable, then your final public and static, these three keywords would be applied. And interface also does not contain a constructor, because again the interface cannot be cannot object of interface cannot be created. So once you cannot create an object of your interface, then it's no point of creating a constructor. So member of the class may or may not be private, but as I said, the compiler would itself add the words public as the access specifier. So if it's private, it cannot be a part of the interface because it needs to be overridden by the other classes because it is 100% abstraction. So you are just defining the function thing and you are not performing any function definition, like function body is not there. So without which it is impossible, there is no use of a function. So you need to compulsorily override that function. But if it is private, you cannot override. So if you cannot override, then that thing would not be possible. Then that's not the use. And interface cannot be extended by class. It is implemented. Like whenever we had to inherit the properties of a class to another class, it's simple thing like keep this thing in mind. Like if you have class and you want to go into class, okay, then this would be extends. Okay, if you have an interface, you want to inherit another interface, then again that would be extend. Okay, but when the things are when the things are what when the things are like one is interface, it is being inherited into a class, then this thing will have the keyword as implement. So when same things are there, like when same things like interface or class of the same variety or same kind, both of them belong, then we use the keyword extend. But when it is like on one kind of thing to another kind, so when then in that case we would use the keyword implement. Implement. This keyword will be used. Implement. Extend. Implement. So basic two things to achieve 100% abstraction and then to have find like multiple inheritance being executed, then we have only abstract methods and final variables. We cannot have private because we need to override compulsorily the thing. So as to override the thing, we should have public, and if we do not mention any access specifier, no abstract keyword is there. By default in an interface, it is being added by the compiler. So we have only the final field like we have here for example, this is what actually happened in the compiler. We have only declared a value that is min equals to 5 and we have declared a function. But when it comes to an interface, how will Java compiler interpret this? So it will have public written, static written, and final. This word will be automatically being treated by the compiler in front of the data variables present in case of an interface. And if it is void print, that means it is a method. So we would have void, a public, and abstract like added before the void print function definition divide by defined by us. So this is what is actually a interface interpreted by the compiler. So now this is how we can have it. We multiple inheritance. We were not able to do it before, but this class can have implement a comma b. That command would work completely fine. So multiple inheritance works in Java by using the concept of interface. And then different types of members which we can have is static, non-static, final, non-final. Usage of static or non-static is when we are concising its accessibility. Like if we have a static function, it would be accessible within another static function only. Or static variable would be accessible within a static class only. But if we have a non-static function, then it can access all the non-static variables, non-static methods into it inside its variable scope. Like inside scope, it can be accessible. But so that is why it is like accessing limit is being added. While final and non-final, final makes a variable value constant. Like it cannot be changed. It needs to be come to that point. while non-final, they are editable at any point during the code. So this is what happens in the class, and that's what happens in the abstract class as well. But there is a thing like abstract or non-abstract class can be there, but in case of interface, the things are not optional. Like in case of data members, it is by default final and static, and the data members are by default public and abstract by default and non-static. So we don't have any option in case of interface. So now the basic difference between abstract class and interface. So abstract class can have abstract as well as non-abstract methods. That is why we had here 0 to 100% abstraction. We had 0 to 100% of abstraction. But here we have only abstract method. So it is going to be 100% abstraction. The abstraction does not support multiple inheritance, while interface has been designed for one of its basic needs was to support multiple inheritance. Abstract class can have final, non-final, static, non-static variables. But interface does not provide any option. It should be static and final. And abstract class can provide the implementation of interface, while interface cannot provide the implementation of the abstract class. It is because in interface we have functions which are being defined in it, and that things need to be overridden by any other class. While abstract class can override the function present in the interface because it has the option of non-abstract as well as abstract methods. So that thing is not possible in case of interface because it is 100%. There is no scope of non-abstract normal method. Now the abstract keyword is used to declare the abstract thing, while in interface we have the interface keyword. The basic difference is like the multiple things and the opportunity to have non-abstract methods, like, and the similarity between these two is that both of them cannot be instantiated, means they both for both of them a object cannot be created, so both of them cannot have a constructor. Then an after class can extend another Java class and implement multiple Java interfaces. But in case of interface, it can implement like it can extend other Java interface only, and it can be implemented by another class. So when it would come to normal class, when it would come to another class, then after class would be able to extend it. But in case of interface, it is to be implemented, like implements is to be written. And then after class can have any access specifier, but for methods present in the interface, it's by default taken as public and abstracted by the from the side of the compiler. Like we don't have any option, the compiler would interpret it in that way. So like we have a owner like interface owner, and if both of them can implement the both of the class can implement this interface, and they have property of their own, and they need to acquire, like they need to have a function definition defined for acquire as well as for dispose. So both of the functions they need to have the desired thing. So this is what is actually the interfaces. So like interface, we have written university, we have given hall, and we have defined a function. So now we have a function variable which is hall, but by default it has been made public and it has been made final by their side. So now when we are having a CSC, which is like implementing like inheriting the properties of the parent interface university, then for it it has one abstract method present in it, and it needs to override that method, and that is why it is overriding this. And as it has implemented, so it will get access to the variables which are being present in the interface. So that is why if we have ECU also, then it should also override the thing, because over abstract methods present in the abstract class needs to be overridden. Non-abstract may or may not be overridden. But interface in itself is 100% abstraction. It is compulsory to override the functions which are being defined inside the interface. Now we have extending interfaces. So our interfaces can also be narrated as I told you earlier. Like if we have interface, as I said, if we have interface inheriting another interface, then it's going to be extending one, because interface extending another interface. And if it has class and then an interface, then it is going to be implement. Like different things implement, same thing extends. And then, as I said, implements, so multiple inheritance. So what we can do, class report is extending employee and is implementing person. So this is how multiple inheritance is being executed in a Java using interfaces. The type of interfaces can be functional interface or Markle interface. Then it just depends on the package and all. And that makes it right. So the last thing of the scoops part would be the concepts of threading and multi-threading. Yeah. So, carbon-integrated communication. So we have already seen the difference between a program and a process. So, like, what is actually it is like if you are new. So new is a function when something is being created. For example, a newborn baby would be in a new state, like it is in the very initial state of a program. Then, after you have been added, like you have added to learn, like you were asked to learn a few things like running or maybe talking. So once you have acquired those properties, then you come into the ready stage. Now in ready stage, there can be a different thing. Like you can go into the running state where we are performing, we are waiting state, that may be the resting state. And after the running state, after all things have been done, which are interrelated, like ready, running, and waiting are all interrelated. And once you have run the thing, then you can move toward the termination of the code. So yeah. So every process would have a multiple threads linked to it. Like there would be the certain things which needs to be done inside a process. They may be run, wait, sleep, or different kind of functions which would be present and that would be communicated to the program at various levels, which is actually a new stage. So for multi-threading or threading, we have already existing interface, which is called as the runnable. So runnable is nothing but it is a interface which is already existing in Java compiler, and this would have a lot of functions written in it which we might or we must override some of them and get our works done. So there can be different threads for performing different functions like run, wait, new for creating new thread, then run, and different threads can be created accordingly. So like thread class, we have a thread class also present. Like if we can extend thread, or we can have implement runnable. So we have a class as well as an interface present with us. We can use any of them, and the thread class have the four different types of constructor present in it. Okay, thread is like you are joining the string, like you are like in case of DNA, it's a very long thread. So like when you are joining the whole things and you are making your code into a process, like you are asking them to go through various stages of a process, go through various developments. This is when a thread is being developed, which will help us to perform sequential things. So then we can have a constructor which can, like when we are creating the object, that time we can have a thread which is like non-parameterized. It can have a string. It can have an object of runnable interface. It can have object of interface, or we can have a string name. So these are the things which we have. Now, like to us to start the start the thread to start the process, we have the keyword of public void run. So when we are run, the action it is like we have kept the thread into action. Now start the execution of the thread would start and sleep when we pause. When we want to pause temporarily the execution of a certain part, then we will make that go into the pause state, and it would be paused for that milliseconds which will be given in that bracket like public void sleep, and in the bracket we must give a value like 100,000 for that many milliseconds. The code execution would be paused. So we have either an interface, we can extend, like implement that. We can implement the interface, we can extend the thread class as well. So they have the respective like run function in the interface which we need to override, and then we can have different functions of our own, and if we are having a thread class, we can override the functions accordingly in this manner as well. So like as we said, newborn till so if it's going towards the runnable thing. So now it has started to grow, it has started to evolve. It goes into the runnable stage. Now in runnable stage, you want to have like put your things into action, like running, performing something. Then we have the yield task. But if you want to rest, wait, like if you want to stop performing anything or execution at that moment, then you have the concept of block thing, like you are suspending the thing for a while. So you have wait, suspend, sleep, resume, and in every bracket you give a certain time period, and for that many milliseconds it would be stopped, and the data type for that is long, so you can have quite a time for that. Then in the runnable stage, when you're going to running stage, that means when you're putting your things into action, at that time it would be into the yield stage. When you are giving something as output, so there is a yield, there is an output. And from any stage, like from the new stage, from the run stage, or from the running stage, that is the action stage. At any point, you can go to the stop stage and you can terminate the code. So from any stage, you can directly reach to the stop stage, that is the termination of your code. So like if I created a thread that is my thread class and I'm extending the thread class and then I'm overriding the run function. So like public void run and then I can create my old things or I can refer to the like super dot things and we can run the function which is defined in thread. Now we can create the object of my thread and we can call t1.start. Now t1.start is a part which is existing in the thread class because thread class has certain functions of its own. Like we have a lot of functions defined in it, so they can be inherited directly from it. And we have to like call the function definition for the run function if we are using the interface as well. So runnable interface is there. Run you have to use, so you have to override the run function, and then we can use the other function like start function or stop function, whichever function we want. Like this also we have the properties like name of our thread, and as I told you we have four constructors. One of the constructors would be like thread with string name, so we can call super with the string name as well. Then we have to override the run function. We would override the run function. We would create like do whatever is there, and once we yield, it goes into the running state, that is the execution state. And here initially, we don't like if we use this thing only, we don't have any fixed pattern like which thread would be executed at what point. We are not aware of that, and that is a one problem. So, as to solve this problem, we have the concept of synchronization, which we will be dealing in a few minutes. So, like it's the thing that thread behavior is unpredictable because which execution of the thread will be executed at what point, at what step, at what stage is not in our control. Like here, thread 1, then thread 3 is getting executed. Like thread 1 execution is thread 1 execution is not completed. Instead, thread 3 execution has started, then thread 1 is executed, then thread 2. So likewise, there is no order. That is why it is said as unpredictable. Like it is not predictable, it is not under our control. And and then the execution will always start from the main method, like the class which has the main method. The execution would start from then we have to override the run method, and then we can use the start method and keep our thread going and yield accordingly whatever is the purpose. So these are some of the properties which we have with current context, which help us to get to know which of the thread is executing at that moment of time. Then these are the things which will just set in things for you, like what are the thread, which is the thread which is executing now, what are the things you can change. So simply giving some values to it. And there is one more thing, that priority. Thread sometimes get executed according to priority as well. So now instead of using synchronization, we can also have the thread priority thing. Like if we set the priority of a thread maximum, then that thread would be executed first and then the second thread would be executed. So based on the priority also we can do things like synchronization using the priority thing. So like the thread communication which I was telling, like we have void run, then notify. It will wake up a single thread that is waiting on the objects monitor. Like we have given us sleep. Now sleep, it was waiting for its turn to be executed. So now it is in a sleep or a resume kind of thing, like we have suspended it for the timing. Now if you write notify, then that particular thread would be notified that your execution is going to begin again. So start working. And if you write notify all, then all the thread will be put into action and they would start getting executed. Like there would be all the threads would be getting executed. So like here we have a chat kind of thing. So now here we are used the synchronized keyword because synchronized thing is there because if you're having a question now without getting an answer, you're not asked to go into the answer thing. Like question is when like conversation is fruitful when there is a two-way communication. So for that we have used the keyword synchronized because for synchronized what will happen? You ask a question, then another key like things happen in synchronization, then answer would be executed. Then again you can have your question and answer. In this way, there will be a proper communication between the two things. That is why we use synchronized keywords in it. Like so you have given hi, so you get an answer hi. Then you ask how are you, then you get an answer, then the next thread gets executed through notify. So through notify we are waking up that particular thread in it. The next thing which we have is types of synchronization. So there can be process synchronization or we can have thread synchronization. So in process synchronization, what will happen is like we have thread 1, thread 2. So like if we are trying to show display the table of 2 and 3. So in process synchronization, first table of 2 will be printed and then table of 3 would be printed. In case of thread synchronization, we saw in the previous thing that message communication, there we had the thread synchronization. So we have like synchronized, we have used what get some of the arrays. So we are having a synchronized keyword which is being added and then we are getting the sum of the array. And then we are having the thread dot sleep. If any exception comes, then it need to be handled. Like for multi-threading and all, exceptional handling should be there because a lot of time different kind of exceptions are there. So exception handlings are really important when you are using threading. So when we create the instance that is match service, we introduce the interference in the threads. Like we have created two, like thread 1, thread 2, thread 3, thread 4, and we are starting all the fours at a time. So then what will happen is it will be executed at different times. Then what will be the output? So firstly, thread 0 is executed, then thread 2 is executed, then thread 2 is executed 0. So like this, what is actually happening? Thread 0 and thread 2 are synchronized like overlap, like once 0, then 2, 0, 2 like this. In synchronization, things are happening in the same way. 1 and 3 thread would be there where thread 1, thread 3, thread 1, thread 3, like that thing would be synchronized. Now, if we use the synchronized keyword like here we are using the notify all thing, but if we use only the synchronized and static thing, like there we are synchronized, but here we have made synchronized and static, then the difference would be thread 0 is executing completely, then 3 is executing completely, then thread 2, and then thread 1. So it can be like when we completely execute one thread and then the other thread, another thread, and another thread. That can be one option. And another option can be when we are having two simultaneously execution of threads, which is important in terms of like the chat things, where what happened is we wanted one-on-one communication, one after the another one. Then like there are certain advantages like inconsistent data is getting prevented and we are getting a synchronized as well as well structured data. And acts like there are shared, like the resources are shared equally among the threads when their turns comes, and there is no uh, race for that data. But the disadvantages is that when there are large number of threads present, so one thread is first executed different things and then the another thread execution starts. So all the other threads are kept in the wait position and only one thread is executing at a time. So as this is the case, so what will happen? It will be difficult for them to handle the things, and it would take so much of time to get all the things done. While in case of unsynchronized thing, 1, 2, 4, 5, like that, once one block gets executed, it's free, the thread can execute. But in synchronized, that cannot happen. So it is sometimes very time consuming, because as they want independent resources, so they are waiting for their sources to be empty. So this is what is actually multi-threading and threading in Java. Yeah. So uh, that is all from this session. Thank you very much. And then let's take the Q&A session. Yeah, so you have asked that can non-abstract class have abstract methods? No. Like for non-abstract class, normal class which we develop, we can only have functions which are defined in it, which are non-abstract. Now, abstract class has been added, which can only have either abstract class, abstract methods, or non-abstract methods. But non-abstract class can have only non-abstract methods because they have 0% data abstraction. For data abstraction, we have abstract class and interface to be used, which can have abstraction involved in it. But abstract class can behave as a non-abstract class in cases when there are no abstract methods present in it. Okay. So, yeah, if you first, there was a question regarding thread. Yeah, so first let's understand that. See, what actually thread means, like a code is like a combination of functions and all present in it. And when you have like execution of different codes at different times according to our needs, according to the mathematical things, then it becomes a process. The thread is what? It is a small segment of a process. Like whole process would be divided into small things, and that would be referred as thread, which would be performing some time. Main advantage of using thread, as I told you earlier in that diagram, from any stage we can go into the terminate stage at any point. Like at any point we can go into the terminate stage by using the stop function. Then it takes less time for creation because anytime you create an object, you can create a thread at that time, and you can override the function already existing, and you can create your functions as well. And then when you have a single action to be done a multiple of time, then we can have multiple threads running, and at the same time we can have like we don't need multiple programs. From one thread we can execute it multiple times with multiple values, and by creating just a thread which is actually an object. Okay, I hope that this is clear. Then how yeah, I will share the uh, QR for attendance as well. Give me a few minutes. And how you learn Java. See, for learning Java is basically once you would try attempting questions, you would try attempting like different type of scenario based questions and all, basic questions as well. With practice, you would be able to learn Java better. Like you just need to be a problem solving approach. Like you need to be able to have kind of critical thinking kind of thing. You just need to practice logics and all, and then you would be able to advance it. So, what is the difference between stack and heap? Okay, like stack is kind of a data structure. Like this thing we will do detail in the data structure. But if you want a basic difference, like stack is a last and first right count of principle. Like in an array or in a linked list, you enter a lot of elements, and the one which is at the top gets popped out. So in stack, we have push and pop function present in it. So that is what is actually a stack. It is a kind of array of elements, or it is basically a linked list of elements. Where what we are doing it, we are popping or pushing in a value into it, or we are popping out a value out of stack. And in case of heap, is a part of a binary tree. Like we have a binary tree, there we have max heap and min heap. Now there are two types of heap. Max heap, what happens is like a binary tree. Oh, wait, like if I try to draw a binary tree, here we will have A maybe. Here we will have B. Here we will have C, D, E, F, and okay. So now this binary tree will be referring to a heap under two special condition, either max or min. Now this is your parent node and this B and C are the child nodes for A. So it would be called as a max tree when all the parents would be greater than the child node. Like A should be greater than B, comma C. B should be greater than D, comma E. C should be greater than F, comma G. So if this condition follows, then it would be a max seed. If B is less than D and E, and C is less than F and G, and your A is less than B and C, then it would be called as mean hit. Now, basic property is when the highest value of your binary tree is present in the root, like the first node is referred to as root, and this node are referred to as leaf. So the root node is the highest value in case of a max heap. In case of a mean heap, the value of this would be minimum, but it should satisfy the other properties as well. This is what is actually a heap, concept of heap. Now if I tell about stack, stack is kind of a linear data structure. Like here, it is not linear because it does not have a only one successor and predecessor. Like here we can have two childs, we can have like it's not a unique predecessor or successor. So that is why it is a non-linear data structure heap, while stack is a linear structure because we have kind of containers where we have values stored. Like if we are entering the value, it will be a push function, and there we have like, and if we want to take out, that is the pop function, and it is last in first out, whichever is last will be popped out first. So this is what is stack, and stack is basically linear because it has like 10 has no like predecessor, but it has successor. It has a successor and predecessor. So unique successor and predecessor makes it a linear data structure, but in case of binary trees we don't have that unique one. So it is kind of non-linear data structure, and heap becomes a non-linear data structure, while stack becomes a linear data structure, and there are changes in its formations and all. I hope you got this. Yeah, I will share the QR code. Yes, I hope all of you can see the QR code, so you can scan that and submit your attendance. Hello, of course. Should I end the session? For basic concepts, I have taught them. For codes, if you want, I can have a session. But maybe on Sundays they might not join. Ah, yes, 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 yes. Yeah. Hello. So for 2 days we have done this sessions and after your exams, when all the quizzes and all would start, we will have sessions again based on your response and needs. We can have coding sessions and all where I would be showing some implementations of what we have learned in these 2 days. So if you have any questions, you can stay back. Otherwise, you can leave.